Hi friends, here we are going to discuss the chapter Polynomials. We have already learned in previous classes about polynomials. So in this video, I will be dealing with the general form of polynomial, degree of a polynomial, classification of polynomial, zero of a polynomial, geometric meaning of zeros of a polynomial. Now we can go deep into the general form of polynomials. Let Px be a polynomial in x, then Px equal to a0 plus a1x plus a2x square plus etc. an x raised to n, where a0, a1, a2 etc. an are real numbers and these are the coefficients. Here the variable is x. The power of x must be non-negative integers. Now we can go to the degree of a polynomial. The highest power of x in Px is called the degree of a polynomial. Let us discuss an example. Px equal to 4x square plus 2x plus 1. We know that x raised to 0 equal to 1. So we can rewrite it as 4x square plus 2x plus 1 x raised to 0. Can you say about the terms? There are three terms. The terms are 4x square, 2x and 1. The coefficient of x square is 4, the coefficient of x is 2 and the coefficient of x raised to 0 is 1. The highest power of x is
2 in this polynomial. So the degree of polynomial is 2 because the highest power of x in Px is called the degree of the polynomial.
Next we go to the topic classification. Classification of polynomial. We can classify the polynomials in two ways, that is based on terms and based on degrees. First one is the classification based on terms. That is, it is based on number of terms in a polynomial. That is, polynomial having only one term is called monomial. The example is 2x and 3x square, etc. Polynomial having two terms is called binomial. The example is x plus 2, x square plus 5, etc. Polynomial having three terms is called trinomial. The example is 2x square plus x plus 1. The next is the classification based on degrees. Polynomial of degree 1 is called linear polynomial. The example is 3x, 2x plus 1. Here the degree is 1 in 3x and 2x in 2x plus 1 also the degree is 1. Polynomial of degree 2 is called quadratic. The example is x square plus 2x plus 3. The degree of this polynomial is 2. The next is the cubic polynomial. In this case, the degree is 3. The example is 2x cube plus 1. The degree of this polynomial is 3. Next we go to the topic 0 of a polynomial. We can find the 0 of the polynomial Px equal to 2x plus 1. To find the 0, First we equate the polynomial to 0. That is px equal to 2x plus 1 equal to 0. That implies 2x equal to minus 1 implies x equal to minus 1 by 2. Here minus 1 by 2 is the 0 of the polynomial. That is, we can say that the 0 is the solution or root of the polynomial. So we can say the 0 of the polynomial is like that a real number k is the 0 of a polynomial px if and only if pk equal to 0. In this example, the polynomial is of degree 1. So it is a linear polynomial. And we can get only 1 0 for this. So we can say that a linear polynomial has at most 1 0. We can do another question. Find the 0 of the polynomial px equal to x square plus 7x plus 12. To find the 0, we first equate it to 0. That is x square plus 7x plus 12 equal to 0. Here we cannot get the value of x easily. So we have to factorize it. That is, we find out two numbers which when add we should get 7 and multiply it we should get 12. Assume these two numbers, that is 4 and 3. Then rewrite one as x square plus 4x plus 3x plus 12 equal to 0. Taking x outside from these first two terms and 3 from next two terms. That is x into x plus 4 plus 3 into x plus 4 equal to 0. That implies x plus 4 into x plus 3 equal to 0. Implies x plus 4 equal to 0 and x plus 3 equal to 0. Therefore, x equal to minus 4 and x equal to minus 3. Therefore, the zeros are minus 4 and minus 3. Here we get two zeros because the polynomial is a quadratic polynomial. Quadratic polynomial has at the most two zeros. In general, we can say that a polynomial of degree n has at the most n zeros. Now we will move on to the last topic of the section, geometric meaning of zeros of a polynomial. First we consider linear polynomial. For this, consider the graph of y equal to x plus 2. To draw the graph, first we prepare a table. Minus 3, we put minus 3 for x, then we get minus 1, then minus 2, 0, minus 1, 1, 0, 2, 1, 3. Then draw the graph. X dash, x, y, y dash. Minus 1, minus 2, minus 3, 1, 2, 3, minus 1, minus 2, minus 3.
1, 2, 3. Then locate the points -3, -1, -2, 0, -1, 1, 0, 2, 1, 3. Join the points. We get a straight line here. We can say that the graph of y equal to x plus 2 intersects the x-axis at the point -2, 0. We know that the 0 of x plus 2 is -2.
Thus, the 0 of the polynomial x plus 2 is the x-coordinate of the point where the graph of y equal to x plus 2 intersects the x-axis. Next, consider the quadratic polynomial x square minus 3x minus 4. Let us draw the graph of y equal to x square minus 3x minus 4. For this, first prepare a table. -2, 6, -1, 0, 0, -4, 1, -6, 2, -6, 3, -4, 4, 0, 5, 6. X dash, X, Y, Y dash. 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, -6, -1, -2, -3, -4, -5, -6, 1, 2, 3, 4, 5, 6. Then we locate the points. -2, 6. -1, 0. 0, -4. 1, -6. 2, -6. 3, -4. 4, 0, 5, 6. Then we can draw the graph. Given the points, the graph cut the x-axis at -1, 0 and 4, 0. Then we can see that the x-coordinates of the points where the graph cuts the x-axis are -1 and 4. So -1 and 4 are the zeros of the polynomial. Thus, the zeros of the quadratic polynomial are x-coordinates of the points where the graph intersects the x-axis.